Hello all and welcome to Study Wizard. ఈ వీడియోలో మనం మోషన్ ఇన్ స్ట్రైట్ లైన్ టాపిక్ గురించి మాట్లాడదాం. ఫస్ట్ థింగ్ ఫస్ట్, ఈ వీడియోలో మనం కవర్ చేయబోయే టాపిక్స్ ఏంటంటే మెకానిక్స్ అండ్ కైనెటిక్స్ డెఫినేషన్స్, డెఫినేషన్ ఆఫ్ మోషన్ అండ్ రెస్ట్, క్లాసిఫికేషన్ ఆఫ్ మోషన్, యూనిఫామ్ మోషన్, వన్ డైమెన్షనల్ మోషన్ విత్ యూనిఫామ్ యాక్సిలరేషన్, వన్ డైమెన్షనల్ మోషన్ విత్ నాన్ యూనిఫామ్ యాక్సిలరేషన్, మోషన్ అండర్ గ్రావిటీ, రిలేటివ్ మోషన్. ఇది కొంచెం రిలేటివ్ మోషన్ కొంచెం ఇంపార్టెంట్ టాపిక్ ఆబ్జెక్టివ్ పాయింట్ ఆఫ్ వ్యూలో. Coming to the definitions, mechanics is a branch of physics which deals with motion of particles, and kinematics is a branch of physics which deals with motion regardless of its causes. అంటే ఇప్పుడు మనం కైనమెటిక్స్లో మోషన్ జరుగుద్ది, కానీ దీని కాస్తో మనకు సంబంధం లేదు. ఈ కాస్తో సంబంధం అంటే న్యూటన్స్ లాస్ ఆఫ్ మోషన్లో చదువుతాం. అండ్ ఇప్పుడు కమింగ్ టు డెఫినేషన్స్ ఆఫ్ మోషన్ అండ్ రెస్ట్. ఇప్పుడు ఎట్ x ఈజ్ ఈక్వల్ టు 0 దగ్గర టైం t ఈజ్ ఈక్వల్ టు 0, x ఈజ్ ఈక్వల్ టు సమ్ x1, t ఈజ్ ఈక్వల్ టు t1. ఈ ఆబ్జెక్ట్ విత్ రెస్పెక్ట్ టు సరౌండింగ్స్ ఇక్కడ నుంచి ఇక్కడికి మూవ్ అయితే దాన్ని మోషన్ అంటాం. అదే x is equal to 0, t is equal to 0, x is equal to 0, t is equal to t1. ఈ కేసు ఏంటంటే రెస్ట్ కేస్. ఇది రెస్ట్ కేస్ కిందలోకి వస్తుంది. ఇప్పుడు కమింగ్ టు ద డెఫినేషన్స్, ఇఫ్ అన్ ఆబ్జెక్ట్ చేంజెస్ ఇట్స్ పొజిషన్ విత్ రెస్పెక్ట్ టు ఇట్స్ సరౌండింగ్స్ విత్ టైమ్, దెన్ ఇట్ ఈస్ కాల్డ్ మోషన్. అండ్ ఇఫ్ ఆబ్జెక్ట్ డజంట్ చేంజ్ ఇట్స్ పొజిషన్ విత్ రెస్పెక్ట్ టు ఇట్స్ సరౌండింగ్స్ విత్ టైమ్, దెన్ ఇట్ ఈస్ కాల్డ్ రెస్ట్. అండ్ ఇంకో పాయింట్ ఏంటంటే ఇక్కడ రెస్ట్ అండ్ మోషన్ ఆర్ రిలేటివ్ స్టేట్స్. అంటే ఇప్పుడు ఒక వన్ ఫ్రేమ్ ఆఫ్ రిఫరెన్స్లో ఒక ఆబ్జెక్ట్ రెస్ట్లో ఉంటే అనదర్ ఫ్రేమ్ ఆఫ్ రిఫరెన్స్లో ఈ ఆబ్జెక్ట్ మోషన్లో ఉంటుంది. అంటే ఇప్పుడు ఒక ట్రైన్ తీసుకోండి, ఈ ట్రైన్లో ఇద్దరు పర్సన్స్ ఉన్నారు, ఇక్కడ ఒకళ్ళు ఇక్కడ ఒకళ్ళు, ఏ పొజిషన్ దగ్గర బి పొజిషన్ దగ్గర. మోషన్ ఆఫ్ ఏ విత్ రెస్పెక్ట్ టు బి ఏమో రెస్ట్. ఇప్పుడు వేరే ఫ్రేమ్ ఆఫ్ రిఫరెన్స్, అవుట్ సైడ్ ఫ్రేమ్ ఆఫ్ రిఫరెన్స్ తీసుకుంటే ఇక్కడ ఒక బర్డ్ ఉందనుకోండి, ఈ బర్డ్ ఒకవేళ ఏని చూస్తే విత్ రెస్పెక్ట్ టు బర్డ్ ద మోషన్ ఆఫ్ ఏ ఈస్ ఇన్ రిలేటివ్ మోషన్. యా. అండ్ ద నెక్స్ట్ సబ్ టాపిక్ ఇస్ క్లాసిఫికేషన్ ఆఫ్ మోషన్. ఫస్ట్ టైప్ ఆఫ్ క్లాసిఫికేషన్ ఇస్ based on its dimensions, 1D, 2D, 3D. In one-dimensional motion, particle moves in straight line. In two-dimensional motion, particle moves in plane. In three-dimensional motion, particle moves in space. X-axis, y-axis, z-axis. And another type of classification is uniform motion, uniformly accelerated, uniformly, non-uniformly accelerated. In uniform motion, velocity of particle is constant. And in non-uniformly accelerated motion, acceleration of particle is not constant. In uniformly accelerated motion, acceleration is constant. Then V is equal to U plus Ut can be applied for uniformly accelerated motion. For non-uniformly accelerated motions, we use integration or differentiation method. Yeah, now some basic definitions. Distance or path covered. Distance definition is the length of actual path covered by an object is called distance. And it is a scalar quantity, it is not a vector quantity, can be zero. Displacement, the shortest distance between initial and final positions of any object during motion is called displacement. Let us say there are 2 points here and one type of distance is this distance, then this can be displacement. And next is speed. The rate of change of position of object in any direction is called speed. Rate of change of position of object, and it is a scalar quantity. Speed is equal to distance traveled by time taken. And next is uniform speed. An object covers equal distances in equal intervals of time.
Remember this. Equal distances in equal intervals of time, then it is called uniform speed. If unequal distances in equal intervals of time or vice versa, then it is called non-uniform or variable speed. Now coming to velocity, the rate of change of displacement of an object is called velocity. V is equals to ds by dt. Acceleration. The rate of change of velocity is called acceleration. A is equals to dv by dt. And velocity and acceleration are vector quantities. And velocity SI units are meter per second. Acceleration SI units are meter per second. And average speed and average velocity. The average speed of a particle in a given time interval is defined as ratio of total distances traveled by total time taken. That means an object covers x1 distance, x2 distance, and within t1 and t2 time, then V average is equals to x1 plus x2 by t1 plus t2. V speed, if this is speed case, if V average velocity is equals if d1 is displacement 1 and d2 is displacement 2 by t1 plus t2. Now coming to uniform motion, if an object is moving along a straight line, covers equal distance in equal intervals of time. Here we have already discussed it. Equal distances in equal intervals of time, uniform speed, unequal distances in equal intervals of time, non-uniform. Now here it is motion. If an object is moving in along the straight line, covers equal distances in equal intervals of time, then it is set as uniform motion or straight line. Now coming to one-dimensional motion with uniform acceleration. We will be having two cases. First one is uniform acceleration. Second one is non-uniform acceleration. Here we use some equations. Here we use differentiation or integration to find out acceleration. In uniform acceleration case, the first equation goes v is equal to u plus at, and second equation is for displacement s is equal to ut plus half at square, and third equation is v square is equal to u square plus 2as. These three are basic and this is derived. Fourth one is derived equation from 1 to 3. Yeah, Sn. This is important in numerical type of view. Distance traveled in nth second is equals to initial velocity plus acceleration by 2 into 2n minus 1. Here, velocity after nth second is equals to initial velocity plus acceleration into time taken. Displacement after nth second is nth second is equals to u into initial velocity into time plus half into acceleration into time square, and final velocity square minus initial velocity square is equal to 2 into acceleration into displacement. One-dimensional motion with non-uniform acceleration. For one-dimensional motion, v is equals to ds by dt, and a is equals to dv by dt, and dv is, and this can be written as v into dv by dx. Remember, this is important. A is equals to v into dv by dx. And here, if the acceleration is given in vector form as a is equal to ax I cap, ay j cap, az cap, where ax is equals to derivative of velocity in x direction with respect to time. Ay is equal to derivative of velocity in y direction, and az is equal to derivative of velocity z direction with respect to time. And now coming to motion under gravity. Here, acceleration becomes acceleration due to gravity. Now we have three equations. V is equals to u plus at, s is equals to ut plus half at square, and v square minus u square is equal to 2as. Now replace A with G. V is equals to U plus dt. S is equals to ut plus half gt square. V square minus U square is equals to 2gx. And the next thing is, if the object is thrown upwards, then G is replaced by minus y. Comment this question. Why G is replaced by minus? Mention it in the comment section. Now, here for objective point of view, we have some solved results to make make your answer quickly. And some of them are: if the particle is projected upwards with a velocity, then maximum height is equals to u square by 2g. Maximum time of ascent is equals to u by g. Time of descent also is equals to u by g. Then total time is equals to 2u by g. And if the particle is released from rest from a height h, then velocity of particle at the time of striking ground is equals to v is equals to root 2g h, where h is height, g is acceleration due to gravity. And time of descent is d is equals to root 2h by g. And next, coming to relative motion. Relative motion of an object with respect to another object is the rate of change of relative position. Rate of change of relative position of one object with respect to another object. Now let us say A is moving in this direction, B is moving in this direction. Then, and let us say velocity of A is v, velocity of B is v. Then velocity of velocity of velocity of A with respect to B is equals to VA minus VB. Now this is case 1. Now case 2. A is moving in this direction with VA, B is moving in this direction. Now velocity of A with respect to B. Velocity of A with respect to B. Remember this numerology is equals to VA minus VB, because this is the opposite direction. If this is positive x-axis, then this is negative x-axis. Negative x-axis. Therefore, VA plus VB. Now, what is the conclusion of this? If two objects are moving opposite to each other, then with respect to one object, other object speed increases. Yeah, that is the result of this. Now, the direction of VA is this, and the direction of VB is this theta. We have some results. VAB is equal to the basic one, root over VA square plus VB square minus 2VAB cos theta. And now coming to the equation, it might help you in some problems, objective point of view. Just remember this: tan beta. What is beta? Inclination of A with respect to resultant. Inclination of A with respect to resultant. Tan beta is equals to VB sin theta by VA minus VB cos theta. Now let me write this here. Tan beta is equal to VB sin theta by VA minus VB cos theta. Yeah, this is the last equation. Now that's it, guys. Thank you for watching our video. Like, comment, share, and subscribe.